Namaste. In this video, we will be covering the general inequality rules. So this table shows that there are 6 main rules that we deal with when it comes to inequalities. And these rules are referred to as axioms. They assume that there are 3 main variables, x, y, and z, and that x is greater than y. Additionally, it assumes that z is an integer. Remember that an integer is any number that can be positive or negative. We will be going through each of these axioms throughout the rest of this video. Also note that there are 4 different types: addition, subtraction, multiplication, and division. Let's first go over the addition axiom. This says that x plus z is greater than y plus z. Remember that all the axioms assume that x is greater than y. So let's say that we had the inequality 3 is greater than 2. How can we demonstrate the addition axiom? Well, if I add a value to each side, then the left side should end up to be greater than the right side. So let's say that value is 2. 3 plus 2 is greater than 2 plus 2. Is this true? Well, yeah, 3 plus 2 is 5, and 2 plus 2 is 4. So basically, whenever you add the same value to both sides of an inequality like this, you end up with another true inequality. Next, we have the subtraction axiom. And this is similar to the addition axiom in many ways. Let's say I have the inequality 5 is greater than 4. How can we demonstrate the subtraction axiom? Well, if I subtract a value from both sides, then the left side should end up greater than the right side. So let's say that value is 3. I do 5 minus 3 is greater than 4 minus 3. And is this true? Well, yeah. 5 minus 3 is 2, and 4 minus 3 is 1. So basically, this axiom proves that when you subtract the same value from both sides, you get another inequality that is also true. So the first multiplication axiom assumes that z is positive, meaning that it's greater than 0. And it says that x times z is greater than y times z. How could I demonstrate this with an example? So let's say I have the inequality 6 is greater than 3. Now, if I multiply both sides by a positive value, like 3, the left-hand side would have to be greater than the right-hand side. So let's do that. Is 6 times 3 greater than 3 times 3? Well, yeah. 6 times 3 is 18, and 3 times 3 is 9. So therefore, we see why the multiplication axiom is true. The second multiplication axiom assumes that z is negative. And it tells us that x times z is less than y times z. So let's say that we start off with the inequality 5 is greater than 1. We would then have to multiply both sides by the same negative number. Let's say that we choose negative 2. So this would tell us that 5 times negative 2 is less than 1 times negative 2. Is that correct? Well, yeah. 5 times negative 2 is negative 10, and 1 times negative 2 is negative 2. So we clearly see why this multiplication axiom holds true. Next, let's look at the division axiom. And notice how here I have a positive z. This is because we assume that z is greater than 0 for this axiom. Let's say that I have the inequality 10 is greater than 8. In order to show this, I would have to divide both sides by the same value and show that the left side is greater than the right side. So let's say that that value is 2. If I do 10 divided by 2 and say that that's greater than 8 divided by 2, is that correct? Well, yeah. 10 divided by 2 is 5 and 8 divided by 2 is 4. For this final axiom, I encourage all of you to try and come up with an example on your own. This division axiom assumes that z is negative and tells us that x divided by z is less than y divided by z. So let's say that I start off with the inequality 10 is greater than 6. In order to prove this axiom, I'd have to divide both sides by a negative number. Let's say that that number is negative 2. So is 10 divided by negative 2 less than 6 divided by negative 2? Well, yeah. 10 divided by negative 2 is negative 5, and 6 divided by negative 2 is negative 3. So therefore, we can clearly see why the division axiom holds true.